Have you ever written some Python code, you hit run, and bam, name error, name X is not defined. And you're sitting there thinking, but I did define it, I swear. Well, chances are the problem isn't that you defined it, but where you defined it. Today, we're going to pull back the curtain on one of Python's most important concepts, variable scope. Let's get into it. Okay, before we go anywhere else, let's lock in one super simple idea that's going to be our guide for this whole thing. A variable, it's just a labeled box. That's it. You give the box a name, you put some information inside, and you're done. Keep that image of a labeled box in your head, because it's the key to understanding everything else we're about to cover. All right, so to figure this all out, we're going to start our journey from the inside and work our way out. We're beginning in the smallest, most private space in your code, a function. I want you to imagine your entire program is a big house. Now, inside that house, every single function you write, that's its own private room. It's got walls, a door you can shut. It is a totally self-contained space. So if you create a variable inside that room, it's like you're jotting down a quick note and sticking it on the wall. It belongs to that room and that room alone. It's a local note, for your eyes only. And this right here is the most important part. Nobody outside that room can see that note. The rest of your code, the rest of the house, has absolutely no idea it even exists. It's completely private, totally sandboxed to whatever is happening inside that one function. And that brings us to the official term for it, a local variable. Just like the definition says, you make it inside a function, and it's only available right there. The cool thing is, once that function is done doing its job, that variable, that little note on the wall, it gets thrown away. The memory is cleaned up, which is great for keeping our whole program neat and tidy. Okay, so we've explored the private room, but what happens when we step outside that door? So we're leaving our little function room and we're walking out into the main hallway, the big open plan area of our code house. This is the main part of your script, the space that all those different rooms are built in. Now, if you hang a big sign in this main area, let's say you write app version equals 1.0 on it, that sign is visible to everyone in the house. Any of those function rooms can peek out their door and see it. That, my friends, is a global variable. So let's just put them side by side. It really all comes down to location and visibility. Local variables are born inside a room and can only be seen inside that same room. Global variables, they're created out in the main hall and are visible from everywhere. It's really the difference between a private sticky note and a public announcement on a billboard. Okay, so we've got our private rooms and the main house. Simple enough. But what happens when the floor plan gets a little more interesting? This is a great question, because in Python, you can absolutely do this. Sometimes you define a function right inside of another function. In our house analogy, this is like building a little recording booth inside of a bigger office. You literally have a room within a room. So what happens if the person in that tiny inner booth needs to look at a plan that's on the wall of the bigger office? See, that plan isn't local to their little booth, but it's not a global announcement for the whole house either. This is exactly where the non-local variable comes in. It belongs to that outer enclosing room. So this kind of variable lives in a weird in-between space. It's not totally private to the inner room, but it's definitely not public to the whole program. It's non-local. It's a way for that inner function to talk to its direct parent without shouting to the rest of the house. Local, non-local, global. Okay, we've got all these different spaces. So how on earth does Python figure out which variable you're talking about? Well, turns out it has a map. This is the million-dollar question, right? What if you have a variable called user_name inside a function, and you have another one with the exact same name out in the global space? Which one does Python use? Well, Python doesn't guess. It follows a very specific rule. The way it works is actually pretty logical. Python always starts its search in the closest, most specific place it can. Then, if it doesn't find what it's looking for, it methodically works its way outward, one level at a time. And that search order has a famous acronym, LEGB. You're going to want to remember this. When Python looks for a variable, it first checks the local scope, the immediate room it's in. No luck? It expands the search to the enclosing scope, the parent room. Still can't find it? It goes global, checking the main house. And if all else fails, as a last resort, it checks Python's own built-in names, like print or len. Local, enclosing, global, built-in. Always from the inside out. Now, at this point, you might be thinking, These global variables seem awesome. They're so easy. You can get to them from anywhere. Why not just make everything global? And look, it's a tempting idea, but trust me, it's a path that leads to madness. And that leads us to probably the single most important piece of advice here. Just because you can use global variables everywhere doesn't mean you should. See, when any part of your code can change a variable at any time, your program becomes wildly unpredictable. A function over here could mess up a value that some other function way over there was relying on, and you'll spend hours trying to figure out why. It is a recipe for disaster. So, let's just wrap this all up. The big idea is that scope is just about how you organize your code's house. Use local variables, those private notes, to keep each room's work separate and clean. And use global variables, the public signs, sparingly, only for stuff that really truly needs to be shared. And always, always remember, when Python is trying to find a variable, it follows that strict search order, the LEGB rule. See, understanding scope isn't just about fixing annoying errors, it's about designing code that's cleaner, easier to read, and way more predictable. It's about being a good architect for your programs. So the real question is, now that you know the rules of the house, how are you going to design your rooms?